Okay, today we're going to learn about how to calculate the maximum number of electrons that can fit in a main energy level of your atom. Now, remember when we drew Bohr models back in chapter 4, we learned that your first energy level can hold up to 2 electrons, the second can hold 8, the third can hold 18. We're going to learn why that is in this unit. The 2n squared rule is a quick, easy way to calculate how many electrons can fit in a given energy level. Remember, n is your n quantum number that we learned about yesterday, and it represents your energy level. So if I were to ask you how many electrons can fit in the first energy level, that would mean n is equal to 1. So plug 1 into the 2n squared rule. 2 times 1 squared. Remember, you have to follow your order of operations here, so you have to square the 1 first. That's going to give you 2 times 1, and then 2 times 1 is equal to 2 electrons. So 2 electrons can fit in the first energy level of your atom. For n equals 2, the second energy level, plug in 2 times 2 squared. Again, you have to square the 2 first. So 2 times 4. So that's going to give you, that's right, 8 electrons in the second energy level. For the third energy level, n equal to 3. Let's calculate that. Plug it into the 2n squared rule. 2 times 3 squared gives you 2 times 9. And that gives you 18 electrons can fit in the entire third energy level. This explains why the third energy level has the d electrons in it. Let's look at our periodic table for just a moment and how this all lines up. For the first energy level, we said we could hold 2 electrons. So if you look at your periodic table, the first energy level contains hydrogen and helium. Those are the 2 electrons we're talking about there. For the second energy level, we said it could hold 8. So let's look at our second energy level. We've got lithium and beryllium. And then we have boron, carbon, nitrogen, oxygen, fluorine, and neon. And that's a total of 8 elements, or 8 electrons can fit in the second energy level. In the third energy level, we have 1, 2, 3, 4, 5, 6, 7, 8. And then remember we learned yesterday that the D block is off by 1 from what it appears. So the D is always number 3, 4, 5, and 6. So we have some third energy level elements here, and there's 10 of them. So we had 8 already from the S and the P block. And then there's 10 here. That gives us the 18 that we just calculated. Let's look at the fourth energy level. For the fourth energy level, n would be equal to 4. So let's plug in for that. 2 times 4 squared gives you 2 times 16 gives you 32 electrons. So we see that the fourth energy level is where our F electrons come in, where the F block is. Now I'd like for y'all to try one. I want y'all to try, what if n is equal to 7? Take a second and figure out how many electrons could fit in the entire 7th energy level if it were completely full. Okay, let's plug into the formula. 2 times 7 squared. So 2 times, what's 7 squared? 49, that's right. 2 times 49 will give you a total of 98 electrons can fit in the 7th energy level. All right, let's look at the next slide. The last thing we want to look at today is called Electron Configurations. We're not going to actually learn how to write electron configurations until tomorrow, But today I want to introduce you to what exactly electron configurations represent and also talk about the 3 rules that govern how we write electron configurations. Electron configurations are simply a way that we represent the location of all of the electrons in our atom. Quantum numbers tells us the address of only one electron, but electron configurations maps out where all of the electrons are. There are 3 rules that govern how we write electron configurations. The first rule is called the Aufbau principle. And this word Aufbau is a funny little word. It's a German word. And what Aufbau means in German is to build. So the Aufbau principle literally tells us how to build our electron configurations. And what it says is the electrons will fill their lower energy levels first. That means the first energy level has to be full before you go to the second energy level. And the second energy level must be full before you go to the third. So it tells us how to build our electron configurations. And it's just like if you were building a house, you have to build your foundation first. The second rule is called Hund's rule. Hund's rule says electrons will fill their subshells separately before pairing up. Y'all, the subshells are the boxes that we draw. Yesterday, when we learned how to draw the boxes and find the box number, the subshells are those boxes. So that's the reason I told you that all the wives have had to come home first before the husbands come home. They've got to be single before they pair up with their honey. And honey, a short name for honey is Hun. So remember, this is Hund's rule. Finally, the last rule is called Pauli's exclusion principle. Pauli's exclusion principle simply says that there's no 2 electrons can be in the same place at the same time. And if you think about it, it makes total sense. Since electrons are particles of matter, and matter cannot exist, two pieces of matter cannot be in the same place at the same time. No 2 electrons can have the same exact location, just like no one else can sit in the same exact chair that you're sitting in right now. Okay, that's the lesson for today. Tomorrow we're going to learn how to write the electron configurations and how to map out the location of all of our electrons.